All right, let's get right into it. Today, we are taking a look under the hood of what is, quite possibly, the most important piece of tech for the future of AI, NVIDIA's brand new architecture, Blackwell. This thing is the engine that's going to power the entire next wave of artificial intelligence. And trust me, by the end of this, you'll see exactly why this little piece of silicon is about to change, well, pretty much everything. So NVIDIA isn't being shy about this. They are literally calling Blackwell the engine of the new industrial revolution. I mean, that's a bold claim, right? That sets the bar incredibly high. It tells you they don't see this as just another yearly update, but as a fundamental shift in what's even possible with computers. So that really makes you wonder, what does it actually take to build an engine for a revolution? What kind of insane technology do you need to create to push us into this whole new era of generative AI? Well, let's find out. So here's our game plan. First, we'll talk about this new industrial revolution. Then we'll dive deep inside the Blackwell Superchip itself. After that, we'll uncover the key breakthroughs, the secret sauce. Then we'll see how it all scales up to become an AI factory. And finally, we'll talk about the big one, the trillion-parameter payoff. Okay, first up, a new industrial revolution. The most important thing to get here is that Blackwell isn't just for the AI we have today. Nope. This was built from the ground up for the absolutely gigantic AI models of tomorrow. We're talking models with trillions of parameters. You heard me, trillions. AIs that can reason and plan and create in ways we're just starting to wrap our heads around. So how in the world do you build something like that? Let's go inside the Blackwell Superchip. This is the core, the fundamental building block, the silicon heart that makes this entire revolution possible. It all starts right here. Just take a second and look at this number. 208 billion. That is the number of transistors they managed to pack onto a single Blackwell GPU. That is more than double the last generation. This kind of density is just mind-boggling, and it's what unlocks a completely new level of performance. So how'd they pull that off? I mean, you can only make a single piece of silicon so big before you hit the laws of physics. Well, NVIDIA's engineers did something pretty incredible. They basically fused two of the biggest chips possible together, connecting them with an insanely fast 10 terabyte per second link. The result? The two chips act like one single, massive, unified brain, a GPU with power we've just never seen before. And now for my favorite part, the secret sauce. What are the key technological breakthroughs here? Because having a huge chip is one thing, but what really gives Blackwell its edge? Let's break down the core tech that makes this thing tick. First up is the second-gen transformer engine. Think of it like a special processor inside the GPU that is built to do one thing and one thing only, run AI. Its killer feature is this new, super efficient way of doing math called FP4. Basically, it lets the GPU use a simpler number format, which lets it process AI calculations twice as fast and cram way bigger models into memory, all without losing accuracy. It's a huge deal. Next, we have secure AI. And this is critical because these AI models are becoming more valuable than gold. Blackwell has security built right into the hardware. It's like a digital Fort Knox that protects the AI model and its data from being stolen or messed with, even while it's running. For protecting that super valuable intellectual property, this is an absolute game changer. And here's something really cool. Blackwell isn't just for training AI. It also has a dedicated decompression engine. You can imagine it as a super fast librarian that can find and unzip compressed data at just blinding speeds. This makes things like database queries way, way faster. So it's a total powerhouse for data science too. And of course, to keep these massive systems running 24/7, you've got the RAS engine. That stands for reliability, availability, and serviceability. It's basically an AI-powered guardian angel living inside the system, constantly watching thousands of data points to predict and prevent hardware failures before they can even happen. Because when you're running an AI factory, downtime is just not an option. Okay, so we've seen the chip, we've seen the tech inside it. But how do you go from one single component to a full-blown AI supercomputer? Well, that brings us to scaling up to the AI factory. The absolute key to making this happen is a technology called NVLink. This is the newest version of NVIDIA's custom interconnect, and you should really just think of it as a private superhighway for data. It's the magic that lets hundreds of these individual Blackwell GPUs talk to each other so fast that they basically become one single, giant, colossal GPU. And how far can we scale this? Well, this superhighway can connect up to 576 GPUs, all working together in perfect harmony. This is the kind of scale you absolutely need to even begin to think about running an AI model with over 1 trillion parameters. And the speed of that highway, it is a staggering 1.8 terabytes per second. It's honestly hard to even wrap your head around that much data flowing between these chips every single second. It's this insane bandwidth that keeps all 576 of those GPUs working as one. All right, which brings us to our last and maybe most important section, the payoff. We've talked about a ton of cool tech and some absolutely massive numbers, but why does any of it actually matter? What's the so what here? Well, here it is. It's not just about raw power, it's about the economics. This chart here shows that a $5 million investment in a Blackwell system can generate $75 million in revenue. That's a 15x return on investment. This is technology that turns computing power directly into profit. And the performance leap? It's just astounding. A full system of Blackwell GPUs can deliver real-time answers from trillion-parameter models 30 times faster than the previous generation. That's the difference between a chatbot that feels a little slow and laggy and an AI that you can have a seamless, real-time conversation with. And the best part is, this isn't just for a few giant tech companies anymore. The Blackwell architecture is powering a whole ecosystem of products, from massive systems for data centers all the way down to a DGX station, which is essentially a personal AI supercomputer that can sit right on your desk. This makes trillion-parameter AI accessible to way more developers and researchers around the world. So let's end with this thought. We now have the technology that makes building and using these massive, city-scale AIs not just possible, but actually practical. With this kind of incredible power becoming so much more accessible, the only real question left to ask is, what problems are we going to solve next?